In this video, we're going to look at a certain type of variable called an accumulator. We'll use it all the time with loops, and we'll look at nested loops. So there are two special types of variables you need to know. We've already introduced the counter variable in the for loop, which is any variable you're using to count. You usually initialize it to 0 or 1. I myself like to initialize it to 0 before the loop because I like to think I haven't counted anything. So why should I start it at 1 if I haven't counted something yet? And then it'll become 1 in the loop. That's my preference. That's not the way it has to be done. I also want to let you know these are my naming conventions that I like to do to help me with the readability of code. So if what I'm doing is counting a variable that I call test, then the counter variable is test count. If I'm counting seats, then my counter variable will be called seat count. Sometimes I get lazy and I take the O and the U out and just do CNT. Now, accumulator variables, you know what they are. They're a running total. So if you ever go to the grocery store, you take a look at the screen as the items are being scanned, you will be seeing your running total of what's been scanned so far. And that's just, that running total is an accumulator. Obviously, we need to have those types of variables. They almost always have to be initialized to 0 because before you scan anything, say at the store, you don't know anything. So you initialize it to 0. Here's my naming conventions. I like to use total in front of the variable that I'm accumulating. So if I scan one price, the accumulator is total price. If, let's say, there's going to be 3 test scores and I need to add them together. So if the variable is test score, my accumulator is total test score. Stock value, total stock value. Hours, total hours. This is an example of an accumulator to output a total. Due to limitations of what we know so far, I'm going to have a for loop that assumes you have exactly 4 products. This is the disadvantage of a counter-controlled loop. At the grocery store, they don't count how many products I have ahead of time. The loop's going to continue to scan the next item until the total button is clicked. But for simplicity, let's just say it's going to be exactly 4 items. In this code, notice before the class, I'm importing a library called java.util.scanner. And what that does is going to allow me to input a value from the user when the user is running the software. It has nothing to do with the scanning at the grocery store. It's just the library for input. You will be talking about this more next week. In main, I'm going to declare my variables and initialize my accumulator. I do that before the loop. So here is just price, the price of my 4 items. But here's my accumulator, total price, and it's initialized to 0. I decided to make it double because many times prices have decimal places. Here is the scanner object, and I'm creating a scanner object so I can get input from my keyboard. This is just going to output at the top of the quote receipt some information. And now here is the loop. Now, most of the work's done in the loop. So I'm going to loop 4 times. We're going to prompt enter price, and then we're going to get the price using that input object. So the input object has a method called next double. Why double? Because price is a double. Since I'm putting it in price and price is a double, I'm going to do input.nextDouble. That's going to get the input from the keyboard and assign it to the price variable. Next, I need to take that and put it into the running sum, which is my accumulator total price. Simply doing total price plus equals price. What does that mean? That means take what you have in total price so far and then add price to it and store the result back into total price. After the loop is done, go ahead and print out the total price due. I'm going to go ahead and run that in NetBeans. Here's my program, Accumulator example 1. I'm going to go ahead and run it. And down here in the output, it's prompting me for a price. Let's say I buy a can of corn for 89 cents. So what's going to happen is that 89 cents is going to go into the accumulator variable. Let's say I buy some eggs. They're pretty expensive now. And let's buy some milk. And we'll buy a loaf of bread. That's my 4 items. So when I hit enter, the for loop is going to be done. And my output of how much is owed will show. Total due $12.78. It's just a small, simple example. Way more to actually writing something like this. But I want you to notice that before the loop, I output my header stuff. This is being done in the loop as well as accumulating. And then this output, however, of the accumulator happens after the loop. Now let's look at the nested for loop. So as you know, a for loop can have many statements inside of it. What if one of the statements was another for loop? Then you would have a for loop inside a for loop, and that's what a nested for loop is. If you have one for loop inside of another for loop, we're going to call the inside one the inner loop, the outside one the outer loop. The inner loop will execute many times for every one iteration of the outer loop. I like to compare that in physics to gears. You got a small gear and a large gear. Okay, the large gear may rotate once while the small gear has rotated many times. I hope that's a good analogy. Anyway, let's say the outer loop is going to loop 3 times. The inner loop is going to loop 5 times. So the outer loop will start number 1, and then the inner loop comes in and has to do 1, 2, 3, 4, 5. Well, then it's done, and then it comes back out to the outer loop and does the second time. Well, then the inner loop gets hit as far as it knows. This is the first time it's done it. And then while the outer loop stays at 2, the inner loop's going to 1, 2, 3, 4, 5. Oh, the inner loop is done. So then it kicks back up to the outer loop at 3. And then we go into this loop and starts the inner loop all over again. 1, 2, 3, 4, 5. Oh, the inner loop's done. So it checks the header of the outer loop, brings it to 4 and says, oh, that's too many. We're only supposed to loop 3 times. And then the nested loop is done executing. So as you see, every one time through the outer loop, you must do the complete cycle through the inner loop. Well, here's an example, a clock simulator with hours and minutes. So every 1 hour of a clock, you do 60 minutes. Oh, here's the next hour. Oh, you got to go through all 60 minutes. Okay, here's the next hour, all through 60 minutes. So I hope you see the analogy here. I have a for loop. In this example, we never print 60 when we get to minute 60. So I started minutes at 0 and went to 59. But we never, for hours, we never print 0 for hours. So here I went from 1 to 12. And then inside of this loop, we just print with a printf. This code means D for integer, which is hours, and D for integer, which is day. And of course, that's new line. But the 0D means I wanted to output 2 digits. And if it's less than 2 digits, like a 9, I want you to print 0, 9. How many times will this loop? Well, whenever you have a nested loop like this, and they're both counters, that's going to loop 12 times 60, because this will loop 12 times, and that'll loop 60 times. Let's take a look at the output. So here is the clock simulator. Let's go ahead and run it, and it's going to output, I believe, 12 times 60, 7,200. So look how fast it did that. But it's just outputting 7,200 lines. Obviously, it's not really totally simulating the clock. So if you really wanted to simulate a clock, what you're going to have to do is add logic right there to make it pause for a minute before looping back up. So you can actually put a little wait statement in there. That's more than what we're going to do right now, and then it will simulate a clock. Suppose you wanted a 24-hour clock. Well, you might simply say, because this is just a 12-hour clock, you might just simply say, I'm going to print military time. But if you didn't want to print military time, you could have this huge if statement. Okay, if hours 13 print 1, if hours 14 print 2. But there is an operator called the modulus operator, and that modulus operator is really nice for converting the 13 to the 1 and the 14 to the 2. We'll show you how to do that the next slide. And also, I will need an if statement to decide whether to print AM out or PM out. So let's look at the modulus operator here. What's the mod operator do? It is the remainder of an integer division. If the variable hour contains 1, the modulus operator in Java is the percent sign. So this is reading 1 mod 12, and that's equal to 1. How did we get this? Well, one integer divide 12. Back in second grade, you would say, well, that's 0 with a remainder of 1. You remember that? And that's what this is. That's the remainder of 1. Same here. 2 mod 12 is 0 with a remainder of 2. And so you can see for each hour until you get to 12, the modulus is simply going to be the same as the hour up to 12. When you get to 12, 12 mod 12 is 0, and that's not what we want to output. Why is 12 mod 12 0? Well, 12 divided by 12 is 1 with a remainder of 0, and that's this. So it looks like when I have a 12 for hour, I'll need some logic to avoid outputting 0. Well, but for 13, it actually will be 1, because 13 mod 12 is 1, right? 12 goes into 13 one time with a remainder of 1. So 13, 14, up to 23, this will give us the correct value. And then we'll get to 24 and we'll have the same issue again that we did with 12. So we'll have to figure out logic for that. Let's see how to do that. So here is our clock simulator. There are some changes. Notice on line 18, there's a string variable called AM PM. That's going to switch down here on lines 28 through 31. I'm making the decision with an if, which we'll get to in a few weeks. But if I is 12, it's AM. If it's I is before 12, it's AM. Otherwise, it's PM. Let me talk about I. I am modifying the variable hours on line 22. That is inside the loop. If you recall, I had the loop control variable being hours here. And in a previous video, I had mentioned it's not a good idea to modify the loop control variable. You just want to keep it here. You don't want to modify it. So I decided to take hours out of here and be able to modify hours. The idea is if I is 13, hours is going to become 1. If I is 20, hours is going to become 8. So we would output 8 p.m., for example. All right, so this represents going through the hours from midnight until almost midnight the next night. Then I'm making a decision using an if statement, and we're doing the modulus operator as we just discussed to make sure that hours is displaying the correct value. However, there's the two exceptions, 0 and 12. If I is 0, it's midnight, so I'm going to assign 12. Obviously, if I is 12, hours is 12. Then there's that if statement to decide with AM and PM. Finally, I've done all the work for hours before I even get to my inner loop. Why did I do it here? If I would have moved all these statements inside this loop, it would have happened the same thing. I would always be the same, remember, because that's the outer loop. But the same thing would happen 60 times. And that's just not efficient. It's wasting the processor memory. So I'm having it happen the one time when the outer loop executes, Then we come into the inner loop when the minutes go through 60 times. And we're going to output just like we did before, except notice I have a %S here. So here's my hours. It's calculated above, minutes as before, and also my AM, PM. Let's run this. Take a look at the output we got. It stops at 11:59 p.m. I'll scroll up a little bit. You'll see there's almost noon, and there is noon. And it worked fine. As we said before, to really simulate a clock, we need to add a wait a minute in between every time through the inner loop. Okay, I got another example for you of nested loops. So suppose I think I know how to write, I know how to use the accumulator, and so I know how to write the statements that will say average 3 test scores. So let's say all of you have 3 test scores and I need to write a program to average it. Well, that's fine. I don't need a nested loop. So I would just loop 3 times, get it, and do the average. But what if there were 30 students? Then I would loop 30 times, once for each student, and then inside the loop, get the test scores for that one particular student I'm on. So that's another example of a nested loop. Here is the output you will see prior to the loop. Here's the loop starting here. So prior to the loop, prompting for how many students, how many tests. I was keeping it simple. I didn't want to do too much input. And then here I am getting prompted for the number of tests. There's that scanner object. We'll do input again next week. So here's my accumulator, and I'm setting this accumulator inside of the student, because every time I go to a new student, I'm starting afresh with adding that student's test scores. So you really need to think carefully about where you want to initialize that accumulator. Sometimes it's always going to be before any of the loops, but in a nested loop, it may be inside the outer loop, but before the inner loop. And that's the case here. So here is our accumulator total. It's going to add together the total test scores. Now, for each student, I'm also going to write the student number and a dash. And so that's happening here. It's happening here because I want it to happen every time there's a new student. But I don't want to put it in the inner loop, or I would get student number 1, enter score, student number 2, enter score, student number 2, enter score. I hope that made sense. So think carefully about where you're putting your output, where you're putting your initialization of your accumulator. Now I'm on line 40 and I'm ready to get the 3 tests. So your typical for loop, test equals 1, test is number than the number of tests. Notice I don't have a numeric literal here. I am getting how many tests there are from input. I'm getting how many students there are from input. That helps me make my program a little bit more flexible. And I prompt enter test score, and then it's outputting test here. Test is, again, the counter variable, which will go through 1 to 3. And I'm going to use my input, and since score is an integer, we use the next int method. And then here we are accumulating. We're taking that score and we're adding it to total. After this loop is done, I want to still be in the student loop, but I'm out of the test loop where I accumulated the tests. And for that student, I'm going to calculate the average and then output that value. There it is for the first and for the second student. Let's see what happens if you decide, no, the accumulator needs to be initialized here. So that's what we did, right? If the accumulator gets initialized here, what's going to happen is it's not going to clear out the total. There is a total value for the student 1 score, but it never gets reset if that's not here. So when you're doing the total 2 score, he's going to start with those values added together, and then on top of it, you're adding those values to it. All of a sudden, student 2, who did poor on these exams, has an average of 157. And that wraps up what we're covering for nested loops. Lots of examples in the book, so I hope this helps.